Good morning, class, or afternoon, or whatever time you are watching this. I'm doing this obviously in the morning because I want to make sure I get my self-care routine done, and then I have to make sure that I'm totally ready in time for 10 a.m. meeting with you. But I know your routine may be a little bit different. As long as you're having a routine every day, everything's fine. Make sure you are sticking to a routine though, because it does make your brain a little bit more apt to obtain the knowledge that I'm imparting onto you. So basically what that means is your brain is a habitual thing. It looks for patterns and it wants patterns. It wants to have habits and routines. If you are following habits and routines every day, your brain is more likely to start picking up new patterns, like the patterns we're going to do today in math. Today actually really is all about patterns. These patterns are not those little, square, triangle, square, triangle, square, triangle that you learned in kindergarten. These are mathematical patterns, also known in this case as ratios. So with these ratios, you've learned ratios before at the beginning of the year. We were talking about ratios and rates. But today, we're really kind of doing a little bit of refresh on that and just taking it up just a little bit. So today, example number 1, create 4 equivalent ratios, 2 by scaling up and 2 by scaling down, using the ratio 30 to 80. So you're going to come up with some on your own, but I do want to show you kind of what we're looking for, so some possible answers of a ratio. So if I want to scale down, I'll start with scaling down. I could scale 30 and 80 down to be 3 to 8. Right? Divide 30 divided by 10, 80 divided by 10, you end up with 3 and 8. That's scaling down. Another example of scaling down might be, well, what if I divide both by 2? So 30 divided by 2 is 15. 80 divided by 2 is 40. There we go. I could even make an equivalent ratio that's still scaled down, but it's going to be a scale up from this. So I could double this one. So 6 to 16. There's 3 different ratios that would be equivalent to this, to 30 to 80. They're equivalent, but scaled down. Now, the opposite can be true. We can come up with some equivalent ratios by scaling up. Scaling up is my favorite way to do it. Probably the least used method, but definitely something we could do. So if I want to scale up, I could just double it, right? 30 times 2 would be 60, and 80 times 2 would be 160. There we go. That's scaled up. Notice that they're larger numbers. I can also scale up. Let's multiply by, I don't have my calculator. That's fine. I think I can do this math in my head. What if I just do scale up by 10? I'm going to go up by a whole bunch. So that would be 300 to 800. Voila! C'est complet. So that's really what we're doing. We're scaling up, we're scaling down. To scale down, you need to divide both by the same number. So I'm going to say divide both by n. To scale up, you need to multiply both by the same number, by whatever that same number ends up being. So going down, you end up dividing. Going up, you end up multiplying. Have some fun with this, and I look forward to seeing what you guys come up with. I've got one more for example 1, and that is write a ratio to describe the relationship shown in the table. So here's the table. Right, Okay, so we can write a couple different ratios to describe this relationship. I notice automatically a 2 to 16 ratio. Do you guys see that? 2 to 16. But, so for every 2 hours, 16 pizzas are sold. So I could assume, as long as this is a constant rate, I could assume then that in 1 hour, how many would we have? We'd have 8 pizzas. Now I do want to double check that 1 to 8 is the ratio we're looking for. We do want to kind of keep it as simple as possible, but I want to make sure that this works for all of this. So let's see, 1 to 8. Well, so if it's 1 to 8, we multiply 1 times 5. So it's 5 hours. Then we have to do 8 times 5, which would be 40. Great. So this one works. We know this one works. So that's how we came up with it. Let's try here. 1 to 6, we multiply by 6. So 8 times 6 is 48. Good, that one works. And then come here, 1 to 10, we have to multiply by 10. So 1 times 10, 8 times 10. Great. It works. So our ratio, I'm going to make that nice and big so you can see. Our ratio is 1 to 8. It's easier to come up with a ratio if you start out by coming up with a non-simplified version. So you take 2 to 16, and then you try to divide it down as close, or down to a prime number, really. 1 would be ideal, but sometimes that's not possible. Sometimes you have to go down to 3 or something like that. But in this case, we're able to go down to 1, which means that there are 8 pizzas being sold every hour. And we just confirmed that that rate stays the same. You are going to do now, well, you'll finish example 1, come up with some ratios of your own, and then move on to exercise 1 and exercise 2. And that's it. Those are the only ones you're going to do. You do not have to do the problem set this time. I know, right? Consider it a present of sorts. Almost like it's a present. I don't know.